So we're just going to have probability that just involves geometric measures. Ooh, I wrote a little big. We'll get it in there. Geometric measures such as length or area, and primarily length and area are two things that we're going to be dealing with. All right, note there are three ways that we can express probabilities. The first way is I can just leave it as a fraction. A fraction might be maybe 1/4. We could change that to a decimal. Well, a decimal of 1/4 would be 0.25. And finally, I can do it as a percent, which would be 25%. All three ways are acceptable answers for probability. All right. I typically lend towards just leaving it as a fraction because I don't have to bring out my calculator or anything, especially if it's a weird, like 1/7. I'll probably just leave it as a fraction. All right, the first kind of probability we're going to talk about is length probability. That is basically I give you a length, and I give you a length within that length, and I ask what is the probability that there's a point somewhere on that line. So it says if line segment AD contains another line segment BC, so BC is somewhere on AD, and a point on the entire section is chosen at random. What is the probability that that is actually on segment BC? In other words, I set up a line like this where I have a long line and a short line somewhere in the middle. And I close my eyes and I need to point to somewhere on the line. That's pretty close. Somewhere on. What's the probability that my finger is between BC? That's what we're trying to figure out. What is that possibility? When we do these probability, what we're going to look for is the part that I want. All right, the event that I want to happen. I want my finger to land between BC. So on the top of my fraction, I'm going to put the length of BC. In other words, that's the part I want. So that's the part. On the bottom, I'm going to put the whole length. All right, because I know my finger's going to hit the line. Well, hypothetically, my finger would hit the line if I close my eyes and if I hit every single time. So on the bottom, we're going to put that whole length, and the whole length would be the length of AD. So with all these probabilities, we're just going to do the part that I'm looking for over the entire sample space or the entire event or everything that could possibly happen. So my finger could land anywhere on this line. That goes on the bottom. This is what I want to happen on top. So what I want to happen over everything that could happen. That is our probability when we're dealing with geometry. All right, so that's length probability. The other one is area probability, but it is basically the exact same thing, except now we're in a two-dimensional plane versus a one line. So if region A contains region B, and point in region A is chosen randomly. So once again, I close my eyes and I hit that board. What is the probability that I am actually in region B? Well, the part I'm looking for is going to be region B, so area of B. Area of B over everything that could possibly happen. I could hit anywhere in area A. So once again, this is my part, and this is my whole. I'm going to add a question to this. What's the probability the point is in A, but not B? So what's the probability that I'm in A but not B? So that'd be anywhere in blue. Who thinks they can do that? We got 2, maybe 3 people. 4. Bree?
Can you do area of A minus area of B over area of A?
Perfect. Because I just want to figure out what's that area that I want to be in, right? I want to be in this section here, which would be A, take away B. So on top we would have area A minus area B all over area A. And that's it, and we move on. Okay, moving on to some examples. So point X is chosen at random on JM. So there's a point that I choose that has to be somewhere on that line JM. Everyone should get the denominators right for our probability. Because our probability denominator is always the whole. What is every possible outcome that could happen? Everything that could happen is on this line. So my whole is going to be that entire length, which is 14. So that means the denominator of both of these is going to be 14. Because I already stated that I'm picking a point X that's on JM. So I have an entire length of 14 that my finger point could land on. The only hard part should be getting our numerator. The numerator is that part that I want. So I want the point to land somewhere between K and L. What is that part of the whole line? What is K to L? It's going to be 7. So in short, it's basically KL, length KL, over the whole length, which would be JM. Which you can simplify down to 1/2. In other words, KL is half of our line segment, so we have about a 50-50 shot of that point being there. All right, the other one says, what's the probability of it not being on JK? Not on JK. Yeah.
11 over 14.
It's going to be 11 over 14, yep. Because not JK would be anything that's not between there. So it would be that total thing here, which would be 7 plus 4, which would give me 11. I'm going to let you do number 2 as homework. All right, it's a nice kind of easy jumping off point, so I would do this one first. We're just trying to figure out what's the chance of a point being in this triangle but not here or here or here, somewhere in this shaded area. I'm going to let you do that at homework. Number 3, every 10 minutes a bus pulls up to a hotel and waits for 2 minutes while passengers get on and off. Then the bus leaves. If a person walks out of the hotel front door at a random time, what is the probability the bus is actually there? Well, so a bus, we just repeat every 10 minutes, yeah.
So, like, what counts as the bus speed?
Well, every 10 minutes he waits for 2 minutes.
But, like, when the bus is stopped, or, like, if the bus is, like, a meter away, like, driving towards the hotel?
We're not going to figure, it is just the bus is there for 10 minutes and then it disappears.
Okay.
All right, so if you want to think of it in theoretical sense, it just appears. So how long is the... So a bus pulls up, waits for 2 minutes, and then it drives off. So as soon as, if any time it's driving, it's not there. Okay? Otherwise, it'd be impossible to figure out, because it'd be based upon bus speed and stuff. So we're just going to go with the purely theoretical, that a bus is there for 2 minutes. You have a 2-minute window to catch that bus. Okay? Now, it doesn't make sense to do 10 minutes over and over and over and over and over forever. So instead of doing that, we're just going to do 1 10-minute time frame because it's going to repeat after this. So we're going to draw a line, and we're going to do 10 minutes. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that's 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes, 7 minutes, 8 minutes. Ooh, I counted wrong. We need a little bit more. 10 minutes. Cool. Oh, I just skipped a line. I was zoomed way in. I did not have it too long. When did someone tell me? There we go. All right, so we have 1 minute to 10 minutes. That's my whole 10-minute cycle of the bus, and then it repeats itself. Well, the bus shows up every 10 minutes. So at 0, the bus is there, and he waits for 2 minutes. And then he's gone for 8 minutes. So that means the chance of me actually catching that bus, well, 10 minutes would be my whole. He waits for 2 minutes, that would be my part. So I have a 1 in 5 chance of catching that bus. All right, a lot of these that get with strings and stuff, the easiest thing is to draw a picture. Because there's a lot of string questions, like if a string is cut certain length. Draw the picture. All right, don't try to make it hypothetical in your head. Just draw a picture. It makes it a lot easier. All right, so we have 1 in 5 chance of actually catching that bus. All right, the last question says, a person who's beginning archery, blah, 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 blah. Basically, you have an archer. And every time he hits a target, it's random. So what are the chances that I actually hit this bullseye? So I want to hit this very center thing. What are the chances of it? First of all, what is our whole? What goes on our denominator? Who can tell me what I'm going to put on the denominator? Mary? I'm going to put 6. Well, I'm probably not going to put 6. Where does 6 come from?
Just did 9 plus 2 plus 3.
But no, we have an entire circle. We're not trying to hit the lines. Yeah.
3.
Won't be 3. 3 isn't my whole. This line is 3, so hitting this line might be 3. Yeah.
9 pi.
It'd be 9 pi. I want to get that entire area of the total circle. So now we're dealing with areas, not with circles. So we're going to say my total area is pi r squared, the total area of the circle, which would be pi times 3 squared. So this is the total area. I want to hit that bullseye. How do I calculate that bullseye? Jamie?
Well, the radius of the small circle is 1, so you do the area.
Yep.
And then it's 1 pi.
Yep. So we have pi times 1 squared. This is my area of my small circle. Let me do this. So area of the bullseye divided by our total area is going to be our chance of hitting it. So like Jamie, so that's just 1 pi over 9 pi. Pi's cancel out and we just have 1 over 9. And that's exactly what we're going to do on that one that I said we're going to do is homework and stuff. In the homework, we're going to calculate our total area. And then we're going to figure out how to get this, just this shaded area. Okay, so we're going to do that in homework, and we're going to work on our homework, and we have time. We have time, so get a good effort at